NASA has released a breathtaking new image of Jupiter, revealing a look at the swirling clouds high above the northern hemisphere. The stunning color-enhanced image was captured on February 7 from 7,578 miles above the cloud tops. At the time, NASA's Juno spacecraft was carrying out its 11th close flyby. Scroll down for video. Jupiter's tumultuous storms have long been a subject of intrigue, and NASA's spacecraft has been hard at work capturing the closest views yet. Recent research has even found that one of the most spectacular storms in the solar system is changing color. Once big enough to swallow 3 Earths, Jupiter's Great Red Spot is shriveling at a rate of 140 miles (230 kilometers) per year, driving its cloud tops upwards. According to a new NASA study, chemicals that give the oval-shaped storm its reddish hue are being lifted to higher altitudes, which may explain why the spot is gradually a more intense orange, researchers said. Scientists believe the storm is likely to disappear altogether within 20 years. Scientists suggest the changes are the result of the storm's shifting winds, which reach speeds of 425 miles per hour (680 kph) as they push Jupiter's crimson clouds counterclockwise around the planet's southern hemisphere. Storms are dynamic, and that's what we see with the Great Red Spot. It's constantly changing in size and shape. And its winds shift as well, said Dr. Amy Simon, an expert in planetary atmospheres at NASA's Goddard Space Flight Center in Greenbelt, Maryland, and lead author of the new paper. Observations of Jupiter date back centuries, but the first confirmed sighting of the Great Red Spot was in 1831. Keen observers have long been able to measure the size and drift of the Great Red Spot by fitting their telescopes with an eyepiece scored with crosshairs. A continuous record of at least one observation of this kind per year dates back to 1878. The NASA team combined these observations with data from NASA spacecraft that have visited Jupiter, from Voyager in 1979 to Galileo in 1995 up to the ongoing Juno mission, which reached the planet's orbit in July 2016. Jupiter's Great Red Spot is a giant oval of crimson-colored clouds in Jupiter's southern hemisphere that race counterclockwise around the oval's perimeter. The biggest storm in the solar system, it appears as a deep red orb surrounded by layers of pale yellow, orange and white. Trapped between two jet streams, the Great Red Spot is an anticyclone swirling around a center of high atmospheric pressure that makes it rotate in the opposite direction to hurricanes on Earth. Winds inside the storm have been measured at several hundreds of miles per hour, with wind storms greater than any storm on Earth. NASA astronomers have said in the late 1800s it was estimated to be about 35,000 miles, about 56,000 kilometers in diameter, wide enough for 4 Earths to fit side by side, measuring 10,000 miles, 16,000 kilometers wide as of April 3, 2017. The Great Red Spot is 1.3 times as wide as Earth and is gradually shrinking over time. They analyzed the spot's size, shape, color and drift rate alongside the storm's internal wind speeds when that information was available from spacecraft. The study shows the storm has been shrinking since 1878 and is now big enough to accommodate just over 1 Earth. In the 1800s it was wide enough for 4 Earths to fit side by side, but what the huge spot is losing in girth, it is gaining in height by measuring how the storm reflected ultraviolet light over several decades. The team concluded that its cloud tops are getting higher because the storm has been contracting. The researchers expected to find the already powerful internal winds becoming even stronger, like an ice skater who spins faster as she pulls in her arms, but instead of accelerating, the storm appears to be forced to stretch up. It's almost like clay being shaped on a potter's wheel, NASA said in a statement. As the wheel spins, an artist can transform a short, round lump into a tall, thin vase by pushing inward with his hands. The smaller he makes the base, the taller the vessel will grow. The Great Red Spot's color has been deepening too, becoming intensely orange since 2014. Researchers aren't sure why this is happening, but it's possible the chemicals that give the storm its reddish hue are being carried higher into the atmosphere as the spot stretches up. At higher altitudes, the chemicals are subjected to more UV radiation and would take on a deeper color. Researchers said they don't know whether the spot will shrink a bit more and then stabilize or break apart completely if the trends we see in the Great Red Spot continue. "The next 5 to 10 years could be very interesting from a dynamical point of view," said NASA Goddard Center scientist and study co-author Dr. Rick Cosentino. "We could see rapid changes in the storm's physical appearance and behavior. And maybe the red spot will end up being not so great after all." Jupiter's Great Red Spot is a giant oval of crimson-colored clouds in Jupiter's southern hemisphere that race counterclockwise around the oval's perimeter with wind speeds greater than any storm on Earth. Dr. Glenn Orton, a Juno mission team member and a planetary scientist at NASA JPL, told Business Insider last month that the Great Red Spot is like a spinning wheel that keeps on spinning because it's caught between two conveyor belts that are moving in opposite directions. The GRS is stable and long-lived because it's wedged between two jet streams that are moving in opposite directions. But Dr. Orton warned its days are numbered. "In truth, the GRS has been shrinking for a long time," he said. "The GRS will in a decade or two become the GRC, Great Red Circle," Orton said. "Maybe sometime after that the GRM, the Great Red Memory." The Juno probe reached Jupiter on July 4, 2016, after a 5-year, 1.8 billion-mile journey from Earth, following a successful braking maneuver. It entered into a long polar orbit flying to within 3,100 miles (5,000 kilometers) of the planet's swirling cloud tops. The probe will skim to within just 4,200 kilometers of the planet's clouds once a fortnight, too close to provide global coverage in a single image. No previous spacecraft has orbited so close to Jupiter, although 2 others have been sent plunging to their destruction through its atmosphere. To complete its risky mission, Juno will have to survive a circuit-frying radiation storm generated by Jupiter's powerful magnetic field. The maelstrom of high-energy particles traveling at nearly the speed of light is the harshest radiation environment in the solar system. To cope with the conditions, the spacecraft is protected with special radiation-hardened wiring and sensor shielding. Its all-important brain, the spacecraft's flight computer, is housed in an armored vault made of titanium and weighing almost 400 pounds, 172 kilograms.
Where the freaks at?